our units are kgs, grams, milligrams, and tons. Those are basic units that we use when we are dealing with mass. So the weight of something, how much matter is in an object. Okay. And then these are some conversions that you need to know by heart. You need to know how to convert between milligrams, grams, kilograms, and tons. Okay, so this is a very good screenshot moment. These diagrams work really well because once you know them, you can't go wrong. My advice is, before a test, you should just quickly write down these diagrams on the front of your test in pencil or whatever. But I would recommend maybe quickly scribbling down the distance one, because the distance diagram was slightly different. It went up by 0 each time. So millimeters to centimeters was by 10. You divide it by 10, then divide it by 100, then divide it by 1,000. This is a really nice diagram because we go up in thousands each time. Okay, so it's 1,000, 1,000, 1,000. You just need to know, when are we dividing? When are we timesing by 1,000? Okay, so keeping this diagram in mind, I'm going to ask you guys to quickly try these conversions for me. Let's see where we're at. Okay, how are these conversions going? Do we have any answers yet? Let me know if you need any help. Nice. Bukancho, I haven't seen you in a while. Okay, go back up. I'm assuming to the diagram quickly. Okay, so I see some of us still busy. Okay, so I can see some answers coming in drips and drabs. Okay. Nice, Fatso. Bile is nice, good. Hanshaw. Nicely done. Zoleka, nicely done. Okay, so I see we are getting the gist of it. Okay, guys, so let's quickly go through these. These are relatively easy questions. We've been doing them since grade 10, saw them in grade 11, and nothing has changed. Still doing them in grade 12. So just a quick reminder. Looking at question A, we have 75 grams to kilograms. So we're going from grams, if we're looking at our diagram, to kilograms. So we are dividing by 1,000. So remember, it's always important to show our working out, because you always get method marks when in maths lit exams. So we'll say 3. Sorry, why did I say 3 there? Looking at the wrong one. $75 grams divided by 1,000 gives you an answer of 0.075 kilograms. If you round it to 2 decimal places, that's also okay. You would get 0.08 kilograms. Don't forget your unit. Okay, and then B, I saw quite a few answers for B. We are going from tons to kilograms. So we're looking at tons in our diagram to kilograms. So we're following the arrow this way. So we are timesing by 1,000. Okay, so let's just quickly reset the chat because it's all over the place at the moment. Let's have a look at C. What did we get for C? 28 grams, 2 milligrams. What did we get? Mango, no worries. It's been a slow start this side too. Okay, question C. Yes, Soleka. So, nice. Okay, good. So we had to times by 1,000. And don't forget your units at the end. Nice. I can see a lot of you remembering the units. Well done. Okay, question D. What did we get? Mbali. Just check your answer there. The working out is correct. Nice, Kazimla. Onse, nice. Oleka, Tamia, awesome. Okay, so we're going from kilograms to grams. So if we go to our diagram, we're going from kilograms to grams. So we are timesing by 1,000. Which gives us 30. Okay, next one, E, 0.0002 tons, 2 grams. Nice, fancy, good work. Any takers for E? Nice and Bali, 200. Sepang, yes. Okay. So this one's slightly more difficult because there's two conversions in one. We are going from tons through to grams. So we have to times by 1,000 and then times by 1,000 again. Alternatively, you can count the zeros. There's 1, 2, 3, 4, 5, 6, and ultimately you can just take your question and times by 1 million. Okay, or you can do it step by step, so times by 1,000, times by 1,000, and then you will get 0,0002 gives you 200 grams. Okay, then the next one, 1,492 kilograms, 2 milligrams. Again, same concept. We are going from our kilograms to our milligrams, so it's 2 steps again. And it is timesing by 1 million again. 1, 2, 3, 4, 5, 6 zeros. Or you can do it step by step. Times by 1,000, times by 1,000. Okay, very curious to see what we got for H. Sorry, for G. Don't know where I got H from. Okay, let me see your answers for G. Seofatso, do you still need me to explain E? Question E? Yes, Mbali. Cool. Okay, so we're going from milligrams to tons. So if we have a look at our diagram again, let's pick another color. So we're going from milligrams all the way through to tons. So it's 1, 2, 3 conversions. You can count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we take our number 49,110,763. We are dividing. And we get an answer of 0,049. And there are quite a few other decimal places, but generally we stop at 2. So if I had to round this to 2 decimal places, I look at the 4. Look next door is a 9, so it becomes 0,05. And we're going to tons. Okay, yes, on that note, now that we've finished this exercise, welcome Hugo, standing in for Kia because she's having some issues. So feel free to message Hugo if you need, or if you want to ask him anything, he is here to help you. Thanks, Hugo, for stepping in. Appreciate it.
Thank you for letting me join the class. Please all, I love answering your questions.
You'll find that this class is very quiet. We like to talk over the chat.
Yeah, that means I'll have company.
Awesome. Okay, guys, how are we feeling about converting between units of mass? Just our general kilograms, grams, milligrams, and tons. How are we feeling? Yeah, see, Mbali has asked me to explain G again. So Mbali, if we are looking at the question, we're going from milligrams to tons. So if we go back to our little diagram, can you see that milligrams is on the one side, tons is all the way on the other side? But in order for us to get there, we have to basically take a number, and we could literally say, divide by 1,000, that will get us to grams. Then we divide by 1,000 again, and that gets us to kilograms. But we have to divide by 1,000 again in order for us to get to tons. So you could alternatively say 49,110,763 divide by 1,000. That is your first step. Then you divide by 1,000 again. That is the next step to get you to kilograms. Then you divide by 1,000 one more time to get you to tons, which is where we want to get to. So it's not just a simple divide or times by 1,000. Okay, we're jumping past all the units. Alternatively, my shortcut is that you go and count all the zeros. So you know that it's 3 jumps. 1, 2, 3. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, which is a billion. Divide by a billion straight up, which is what I did in the question over there. And that's how we go from milligrams to tons. Okay, so that's why I do like to use this diagram, because you can visually see how we are going from each unit until the one we are looking for. Awesome. I'm glad you're enjoying it, Prudence, and you're understanding. It's a tricky one. Okay, so we'll practice some more. Okay, so on Monday, you guys had a look at converting between imperial units and metric units. So we're going to touch on that just a little bit, just quickly remind ourselves about the conversions, because these conversions happen in distance, which you do on Monday. They can happen in mass, volume. Okay, so we're going to have a look at it in terms of mass units now. So I have given you the conversion factors in these blocks over here. Now, remember, we use the metric system in South Africa. The metric system is our centimeters, our meters, kilometers, grams, kilograms, liters, milliliters, etc. And mainly in America, they use the imperial system, which is all these different units that we are not used to seeing, like our ounces and pounds, okay, yards, yeah, that's what I can think of right now. So we have to use something called conversion factors to convert between these two systems. It's not a simple divide by 1,000 or times by 10. We have to use these conversion factors given to us. Okay, they will always be given to us in an exam or a question, so you don't need to know these off by heart, because that, yeah, would be impossible. Okay. So like I said, you did try a few of these on Monday. So let's see how we would handle question 1. It says, how many pounds are there in 20 kgs? How many pounds? Remember, pounds is part of the imperial system, and kgs is part of the metric system. So we need to convert the metric units into the imperial unit. So we are going to be looking at this conversion factor over here. So always take a moment to look at the question, see what they've given us, what imperial unit have they given us, what metric unit, and what value. Have they given us a metric value or imperial value? And then you go and look for the correct conversion factor. Oh, and I see we've got some answers already. Well done, Kabile. And Hugo also helping us out here. Okay, so looking at that conversion factor, they tell us that 1 kg is 2,2046 pounds. So if we know what 1 kg equals to, how much does 20 equal to? So in order to work that out, we say our 20 kgs times by the conversion factor, which gives us 44,09 pounds. which is abbreviated LBS, or you can write out the word pounds. Well done. Nice, Ntando. Good. Okay. I'm going to give you guys a chance to do question 2. Okay. If we are going to use that conversion factor, we need to divide. Because in this question, we're going from metric to imperial. So if you want to times, you need to use the conversion factor on this side. Nice, the pun. Okay. You can round to 2 decimal places. Any other answers? Okay, good. So we look at the question. We've got an imperial unit, sorry, metric unit. And we need to convert to imperial. So we're going from metric to imperial. So we're looking at this table over here. And we're specifically looking at grams to ounces. So it's the first one. They tell us that 1 gram is equal to 0.0352. So if we know what 1 gram is equal to get what 32 is, you just times by 32. So 32 times by the conversion factor gives you 1,13 ounces. Okay, great. So I see a lot of you doing that. So you should actually be putting your actual answer in first, and then your rounded answer to 2 decimal places. When in doubt, 2 decimal places. Nice, Bukhansho. Nice, Prudence. Good. Nice, Kabile.
And I think
Okay, looks like you guys have got a hang of it. So I'm going to give you a couple minutes to complete exercise 2. Don't put your answers in the chat just yet. We'll go through it together. So quickly do your calculations for A, B, and C. And when in doubt, Hugo is dropping the tips in the comments for you. Okay, guys, wait, don't put your answers in the chat just yet. No worries, not the only one. I'm giving you time to do all three. Remember to look for the correct conversion factor. Okay, do we have some answers? Let's look at A specifically. Oh, you guys were ready to type those. Koketsu, yes. And I saw Prudence also gave us the answer earlier. Fantastic. A. Okay, so we're going from 4.9 kgs to pounds. We're going from metric to imperial. So we're looking over here specifically. Okay, they tell us that 1 kg is equal to 2,2046 pounds. So technically the pounds are bigger than 1 kg. So our answer needs to be bigger than the 4.9 because we're going to a bigger unit. So it's going to be 4.9 times by the conversion factor, which indeed gives us 10.80. And we are going to pounds, so LBS, or you can write out the word pounds. Nice, and I can see you all getting it. Fantastic. Okay, then B, we are going from grams to ounces. Again, metric to imperial, grams to ounces. So we are looking at the top conversion factor. Again, pay special attention. They're telling us that 1 gram is equal to 0.0352 ounces. So it is smaller. It's a smaller unit. 1 gram is bigger than 1 ounce. So our answer actually needs to be smaller than 360. So we are going to say 360 times by the conversion factor, which gives us 22.18 ounces. So when in doubt, this is similar to exchange rates. You're either timesing or dividing by the rate. So if you're ever confused as to whether you should be timesing or dividing, you just need to try to think about it logically. So specifically for this question, we're looking at grams going to ounces. They tell us that 1 gram is equal to 0.03. So 1 gram is bigger than 1 ounce, technically. So if we are going from grams to ounces, our answer needs to be a smaller value. Okay, which would imply that we are going to times in the situation. So if you do get confused about times and dividing, just think about it logically like that. Okay, C. "21 ounces, 2 grams. Okay, so we are going from imperial to metric. Imperial to metric, because I'm going from ounces, that's imperial, to grams, which is metric. So I'm looking at this conversion factor over here. 1 ounce is equal to 28,3495 grams. So 1 ounce is equal to 28. So we can see grams is the bigger unit. So we need a bigger number. We are saying 21 times by the conversion factor, which gives us an answer of 595,34 grams. So this conversion factor gave us the value of 1 ounce. So if we know what 1 ounce is, to get the value of 21 ounces, you need times by 21. Okay, so Mbali raised a hand. Yes, Mbali.
Ma'am, can I ask? I'm a bit confused. Isn't it when we going from metric to imperial with times, then from imperial to matrix with divide, or do you times in all the?
So it all depends on how you get the conversion factors. If I just gave you that first block, then you would have to do the opposite. Then you would have said, we've got 21 ounces. You would say 21 divided by the 0,0352. But because I gave you this other block as well, which says going from imperial to metric, and we've got 1 ounce, we know the value of 1 ounce. So if we know the value of 1, to work out the value of 28, 21, we just times by 21. So it's not a set. If you go this way from metric to imperial, you have to times. If you go the other way, you have to divide. It all depends on how it's given to you, because you actually have both options here in this particular question. So it's not a set rule that you have to times when it's metric to imperial, or vice versa. I know it's a little bit confusing, but you just need to think about the conversion factor logically. See how it's given to you, and then you have to either times or divide. Okay. I think that one threw quite a few of us off. Okay, any other questions? Can we try one more, but a little bit more intense? If there are no questions, I'm going to give you guys a minute or two to try the let's step it up question. So if we're having a look at this question, a crane can lift a maximum load of 3,5 tons. If a container weighs 6,820 pounds, will the crane be able to lift the container? So if we look at the above conversion factors, do we have a conversion to get us from pounds to tons? No. Okay, so the only conversion we can actually do is pounds to kilograms, right? Can we get from kilograms to tons then? Okay, so our only option is to take our pounds and convert it to kilograms, because that is the only conversion factor we have. But we need to look at tons. And if we go all the way back to the beginning, can we go from kilograms to tons? Yes, we can. That will just be a normal metric conversion. Okay, so sometimes you might need to convert it to another unit before you can actually convert to the unit that you are looking at. So hence, this was a little bit of a tricky question. So let's go and convert our 6,820 pounds to kgs. So because I'm going from pounds to kgs, I'm going to be using this conversion factor. So 1 pound is equal to 0.4535. So I'm going to times by the conversion factor. Wrote it down wrong. 0.4535. So 6,820 pounds is going to be 3,092.87 kilograms. Okay, so we're halfway there. We need to convert to tons. How are we going to do that? We've got our answer now in kgs, but we need it to be in tons. So what are we going to do? Yes, Oleka, we are going to do a normal metric conversion, conversions that we should know off by heart. So to go from kgs to tons, we divide by 1,000, which means the container weighs 3,09 tons. Nice, Kabile. Awesome. But now have we answered the question? We haven't finished answering the question. What did the question actually ask us? Will the crane be able to lift the container? That is what they've asked. We've just shown some calculations. Can the crane hold this container? Yes. So you'll say, therefore, the crane so don't forget to actually answer the question. You do get a mark for this little sentence at the end because that is the answer they are looking for. Yes, it can lift the container. So it still falls within that maximum load range. Awesome, Shells. Good. Okay, so this one's a little bit tricky, and it's possible that they could ask you this in an exam where they don't give you a direct conversion factor. So sometimes you might need to convert to another unit before you can convert to the unit you are looking for. Okay. Let's have a look at volume. So we will continue practicing conversions as we go along through all our courses, and they will pop up again in our revision. So don't panic just yet. So we've done mass. Let's have a look at measuring volume. Volume is the 3D space taken up by a gas, liquid, or solid substance. Okay, our units for volume are liters, milliliters, and kiloliters. Okay, we normally deal with kiloliters with our water tariffs. And again, we've got some conversions that we need to know off by heart. So it's a very good screenshot moment if you want to quickly write it down. Again, Very similar to our mass conversions. We had milligrams. Now we're starting with milliliters. Got our liters in the middle and our kiloliters at the end, just like our kilograms. And again, it's dividing or timesing by 1,000 each time. So you need to remember the order of the units and when you're dividing, when you're timesing. So when you are going from smaller units to big units, you are dividing. When you go from big to small, you are timesing by 1,000. So when you're going from the smaller unit is milliliters and liters is bigger. So if we go from milliliters, our smaller unit to our bigger unit, we divide. Okay, and we read this diagram and work with it the same way we did with our units of mass. Okay, and important, these need to be known off by heart. Okay, so using this diagram, let's do some calculations. I'm going to give you guys 3 minutes to try do A, B, C, D, and E for me. Let me know if any questions. I'll let you know when you should put your answers in the chat. For now, just hang on to them. Okay, let's see our answers for question A. 60 milliliters, 2 liters. Awesome, don't forget your units. Okay, so just to quickly remind ourselves how to use this diagram, we are going from milliliters to liters. So we're following the top arrow. So we are dividing by 1,000. So we say 60 divided by 1,000 gives you 0.06 liters. Okay, whenever you do a conversion in a test, whether it's a question within a question, you will always get a mark for showing your conversion and then your answer. So don't just write your answer only in your test. Okay, then B, 4 liters to kiloliters. Okay, looking at our diagram, we're going from liters to kiloliters. So again, we are dividing by 1000, which gives us 0,004 kiloliters. Awesome, well done. Nice. C, 2 kiloliters, 2 liters. Nice, Juanset. Very quick answer. Nice, Lupo. Okay. So we are doing kiloliters, 2 liters. So we are timesing by 1000. D, what did we get? Okay, so we're going from liters to milliliters. So we are times by 1000 gives us 320 milliliters, which we all got. Well done. Oh, and you guys are also eager to give me the answer for E. And we got, you're having to count all the zeros here. Kiloliters to milliliters. So this is the kind of one we struggled with when it came to mass. Okay, so we are going from kiloliters, we have to times by 1000, and then we times by 1000 again to get to our milliliters. So in essence, we are timesing by 1, 2, 3, 4, 5, 6 zeros make a million. Okay, so 2,4, you can either say times by 1000, times by 1000, or 2,4 times by 1 million, which gives you 2,400,000 milliliters. Awesome. Looks like we did get that for the most part. Well done.